Hello everyone, welcome to ESM classes. ESM means Economics, Statistics and Mathematics. In this class, I am starting with statistics, and in statistics, I will be dealing in these topics. Number one is descriptive statistic. In the case of descriptive statistics, we are studying measures of central tendency. In the case of measures of central tendency, basically we are studying mean, median and mode. Yeah. In the case of measures of dispersion, we will be studying range, IQR, variance, standard deviation. And then graphs, in the case of graphs, I am discussing only box plot, right? Then normal distribution, the very important concept. We need to apply normal distribution concept in different fields. So this is very important topic. In this, we will be starting with mathematical expectation, then normal distribution and the standard normal distribution, and then how to find probabilities if the distribution is normal, right? After normal distribution, again the important topic is confidence interval and hypothesis testing. In this, we have three subparts. We will be discussing about single population, how to find confidence interval, and how to test hypothesis testing in the case of single population mean, in the case of single population proportion. Then we will be discussing difference between two population means and the two population proportions. And last, we want to discuss the difference between two population mean in the case of paired samples. So remember, here we are discussing unpaired samples. Here we are discussing paired samples. So let's start with descriptive statistics. In the case of descriptive statistics, we are starting with measures of central tendency, and in this we have three measures to calculate central tendency. Number one is mean, second is median, and the third is mode. So let's start with mean. Mean or average. Now, what do you mean by the word mean or average in stats? So basically, as per the formula, guys, remember that we are doing sample mean. We want to calculate sample mean, and we denote sample mean by x bar. We denote sample mean by x bar, where x bar equals to summation of xi's divided by n. For example, if I say I have 5 different observations, 1, 2, 3, 4 and 5. Now, if you do summation of all these, what you will get? So 1 plus 2 is 3, 3 plus 3 is 6, 6 plus 4 10, 10 plus 5 15. So we have 15 here. So in this case, my x bar will be 15 divided by 5 because we have 5 observations, 1, 2, 3, 4 and 5. And if you solve this, your answer is 3. Now, in this, we want to know how to and where to apply mean. What are the consequences of applying mean in different data sets? So I have taken 3 data sets. This is my data set X, right? This is my data set Y, and this is my data set Z. In the case of X, the observations are 1, 2, 3, 4, 5, and the mean is 3. In the case of Y, my data set is minus 20, 2, 3, 4, 5, and my mean is minus 1.2. In the case of dataset Z, my dataset is 1, 2, 3, 4 and 20. Now, I will compare Y and Z with X. This is my benchmark dataset. X is my benchmark dataset. Now, if I compare X with Y, so we know that in the case of if you're comparing X with Y, we know that we have 2 here, 2 here, 3 here, 3 here, 4 here, 4 here, 5 here, 5 here. But the only difference is we have 1 here and we have minus 20 here. Now, first tell me one thing. I have changed only one observation. That means instead of 1, I have taken minus 20. and my mean is also changed. That means, that means in the case of mean is taking care of all the observations. It is affected by all the observation. If you change any particular observation, the mean will be affected by that observation. Secondly, here we need to learn a new concept which is known as outlier. So in this case, outlier is that particular value which is quite different from rest of the values, right? So let's say if this is a circle, my values, all values are lying here and some value or one or two values are lying here. So these two values are known as my outlier. Similarly, in the case of dataset Y, we can see that the very different value from the dataset is -20, and in the case of Z, the very different value in this dataset is 20. So basically, we can say that in the case of Y and in the case of Z, we have outliers. The outlier in the case of Y is -20 and outlier in the case of Z is 20. But in the case of X, we can't find any value which is quite different from rest of the other values. Therefore, in this case, there is no outlier. Yeah? Now, basically, if there is an outlier, the mean is affected very much by the outlier, right? So in this case, where there is no outlier, my mean is 3. In the case of outlier, my mean is tending towards that outlier. So basically, outlier is -20. So my mean is now reducing because of this outlier, which is -20. Now compare 3 with 6. We have outlier 20. Now mean is biased towards the positive side because we have outlier towards a positive side or the higher end, right? So we have in the case of Y, we have outlier towards the lower end, and in the case of Z, we have outlier towards the higher end, and the mean is getting affected or very much affected by these two outliers. In the case of Y, the mean is biased towards the negative side. Now, why I'm saying the mean is biased towards the negative side, rest these values, these four observations are all positive, but because of one observation which is -20, your mean is negative, right? So mean is biased towards the negative side because you have outlier which is -20, which is towards the lower side of the observations. Now, in the case of Z, the mean is affected by the higher end value, and therefore if you compare 3 and 6, obviously 6 is more as compared to 3. Why? Because the mean is affected by this outlier which is 20, right? So we know that. So advantage of mean is taking care of all the observation. It is affected by all the observation. What is the disadvantage? Disadvantage is same. Since it is affected by all the observations, therefore it is getting affected by an outlier, and therefore we should not trust this value. This value means in this case, in the case of Y, I should not trust mean value which is equals to -1.2, and in the case of Z, I should not trust 6 value, the value 6, because it is the mean is vectored by an outlier, right? For example, I want to give you one simple example. Let's say in a college, if a college tells you we have or 50 lakhs is the package, right, that students are getting. So the college is claiming that on an average, students are getting the package of 50 lakh. But you have not seen the data, right? Now, if the data set is with you, these are the packages. Student A, package is 2 lakhs. Student B, the package is 5 lakh. Student C, the package is 1 lakh. Student D, the package is 2.5 lakhs, and let's say student E, the package is such that so that their mean equals to 50 lakhs. Obviously, student E package is very high, very high, right? So obviously, in this case, basically college is claiming that their mean package is 50 lakhs, but if you see the data is showing only one student is getting highest package, and it is so high that the value of mean is 50 lakhs, and the rest of the students are getting package which is below or equals to 5 lakhs. Now, after seeing the data, your decision might change whether to go to this college or not. But before seeing the data, your decision is let's go to this college because you will get highest package. So therefore, we are saying that in this case, this is outlier, right? Because of this outlier, your mean is biased towards the higher end or towards the positive value. In this case, we should not trust this value, right? So in the presence of outlier, please don't go for mean value. Now the question is, sir, you are saying in the presence of outlier, we should not go to mean value. Then what value we need to trust on? So the answer is please trust the value of median. Now, first of all, what is median? So, in the case of median, step number one is let's understand how to find median first. Step number one is please arrange the data set in ascending order. Let's say we have data set 1, 3, 5, 4, 2. Please arrange your data set in ascending order. That means xi would be 1, 2, 3, 4, 5. Right? Now, median is, for example, if I arrange all these value here, median is the 50th value, 50th percent value, right? 50th percent value of the data set, right? So basically, it is dividing the data set equally. 50% here, we have data set 50% on the right side, right? This is median. Now, in the presence of outlier, we need to trust median. The reason being, in the case of median, median is not affected by an outlier. So if you want to write, you can write here is median is not affected by an outlier. Yeah. Now, the question is how to calculate median. The formula says that first arrange the data in ascending order, then apply this formula n plus 1 by 2th term. Remember that I'm saying n plus 1 by 2th term. In this case, n equals to 5. We have 1, 2, 3, 4, 5. Therefore, 5 plus 1 by 2th term, right, which is equals to 3. Now, we need to look for third value, right? So this is value number 1, this is value number 2, and by chance the third value is also equals to 3. Therefore, in this case, third term which is equals to 3. Now, for example, if your xi's are 2, 7, 11, 15 and 20, what is your median? Again, we have 5 observation. The third term is your median. In this case, your third term is 11. So in this data set, your median is 11, not 3. Remember that, right? Now, I have said that median is not affected by an outlier. Let's see. In this example, I have taken the same number of observations and these ditto same observations. In this case, in the case of x, we don't have an outlier. Therefore, we have 1, 2, 3, 4, 5. The median is 3. We have just calculated that. In the case of y, again we have 5 observation, and you know that by calculating the median is the third observation, which is this. Therefore, the median is 3. And in the case of z also, we have 5 observation. The median is third observation. The median is again 3. So we can see that in the presence of outlier, the median value is not changing, and hence we can trust the median value but not the mean value. The reason being, mean is affected by an outlier, but median is not affected by an outlier. Therefore, we need to trust the median value and not the mean value in the presence of outlier. But remember that if there is no outlier, then guys, please trust the mean value. Why? The reason being, mean is taking care of all the observations. So mean is taking care of all the available information. But median is not taking care of all the available information. It is taking care of only the middlemost value of the data set, which is the third observation. If your third, in this case, if your third observation is changing, your median is changing. But if these observations are changing, your median is not changing, right? So therefore, we are using median only in one case where we can't trust the mean value, and we can't trust the mean value in the presence of outlier. So basically, in the presence of outlier, we need to use median, not mean. Yeah. Then we have mode. Mode is the most occurring number in the data set. For example, we have xi, which is 1, 1, 2, 3, 4, 5. In this case, 1 is occurring 2 times and rest all other numbers are occurring 1 time. Therefore, my mode is 1. My mode is 1. So let's say we have xi, which is 1, 1, 2, 2, 2, 3, 3, 4, 5. In this case, 1 is occurring 2 times, 2 is occurring 3 times, 3 is occurring 2 times, and 4 and 5 occurring 1 time. In this case, 2 is their mode, the reason being it is the highest occurring number in the data set. So mode equals to 2 here. Yeah. So basically in this class we have discussed about measures of central tendency. In the next class we will be discussing about measures of dispersion. That means we will be discussing about the range, IQR, variance and standard deviation. So keep smiling, keep laughing. I'll meet you in the next class. Bye guys.